Hello, this is Guillermo Campitelli, and this video is the Q&A corresponding to week 2 in the unit BSC302. In this video, I'm going to answer the questions posted in the week 2 forum for Q&A. Now, there are two questions that I'm going to answer in this video. The first one is related to causal models or DAGs, directed acyclic graphs. The question is, I'm slightly confused about the difference between a collider, Z, and a confounding variable, U. Okay, so first of all, we shouldn't associate specific letters to types of structures in a causal model. So a collider could be Z, could be A, could be C, could be B, any variable could be a collider, and the same for a confounding variable. So I'm not saying that that's implied in the question, but just in case, I'd like to emphasize that any variable could be a collider or a confounding variable. So let's see the first example here. Here we've got the case of a common cause. C is a common cause of A and B, because C is causing A, that the direction of the arrow tells us that C is causing A, and C is also causing B. So A and B have a common cause, which is C. Okay. Collider is this case in which we've got A and B and C, but A and B are directing their arrows to C. C is a collider because a collider is the place where two arrows collide, or the variable that is affected by two other variables, or at least two, could be more. Okay, so in this case, C is a collider. In the case above, C is a common cause. Now, what's a confounding variable? That's the question. Okay, look at this third graph. The third graph is the same as this one, but it adds one arrow from A to B. Okay, so A now is having the same role as C in that graph, in the common cause. So A is a common cause. It's a common cause for B and for C. Why is a common cause? Because there are two from A, there are two arrows, one directed to B, so A is the cause of B, and there is an arrow that goes from A to C, so A is a cause for C. So A is the common cause for B and C. Now, let's say we are interested in the effect of B on C. So that's the effect that we are interested in. Okay, in that case, then A is a confounding variable. Why is a confounding variable? Because it's a common cause for the two variables I'm interested in. I'm interested in B and C, and A is a common cause for both of them. So, in this case, A is a confounding variable. Okay, now in this graph, I show exactly the same as in the previous graph. The only difference is that the variables are located in different places, but if you follow the arrows, they will be the same as in the previous graph. Let's see, from A to B here, from A to B there, from A to C here, from A to C there, and from B to C here, and from B to C there. And again, if we are interested in the relationship between B and C. I want to interested how strong is the causal effect of B on C, but that will be affected by A, which is a confounding variable, because A is a cause of the two variables I'm interested in. It's a cause of B and it's a cause of C. I hope this clarifies the difference between a collider and a confounding variable. The second question is about the beta distribution. So this is a question that was in the quiz, and the question is, in a beta distribution with parameters A equals B, or alpha equals B, and B equals 80, or beta equals 80, which of the following values is more plausible? 0, 0.30, 0.50, or 0.80? So the question that was posted in the forum was, I was wondering if you could explain why 0.3 is the answer and 0.5 is not the answer. Okay, so we can do it by going to JASP and actually put the parameters A equals 20 and B equals 80 in the module of distributions corresponding to the beta distribution, and we can get this graph. So this is one way of trying to solve this problem. The other one is we don't need the graph. We can intuitively answer the question. Okay, so remember that we can, for the sake of argument, consider that A and B are successes and failures. In a Bernoulli distribution. In a binomial distribution. Okay, so in this case, A corresponds to the successes and B corresponds to failures. That's always the case. So A will correspond to successes and B to failures. And so if we have 20 successes and 80 failures, that means that we've got 20 out of 100 trials are successes. That means that the most likely probability, which is the parameter of the binomial distribution that these number of successes comes from, is a probability of 0.2 or 20%. Okay. Now, the options here are 0, 0.3, 0.5, and 0.8. 0.2 is not there, but the question is saying which of the following values is more plausible. And remember that the beta distribution is a distribution over values between 0 and 1. So look at the graph, values between 0 and 1. Now, as I explained now, I explained before, and the most probable value is 0.2, like here, 0.2. But this is a distribution, so values close to 0.2 are also are somehow plausible. Now, so 0.3 is here. It has a much lower plausibility than 0.2, of course. But if you compare to the other values, 0.5 is here. So it's much lower than 0.3. And 0.8 is even lower. And 0 is also lower, you can see, but also we know that the probability of 0 is 0, because if you have 20 successes, the probability cannot be 0. Okay, so basically 0.3 is the value that is closer to the most probable value, 0.2, and in this distribution is much more plausible than the other options in the question. Okay, so this is the last question. There were only 2 questions, so please start using this forum. The next one will cover 2 more weeks. This one cover weeks 1 and 2. So in the next Q&A, you can ask anything from the weeks 1, 2, 3, and 4. So feel free to ask any questions. Remember that for any other question you have, you can put the questions in the general forum, and I try to answer as soon as I can. The issue of not asking you not to send me emails unless they are of personal issues. So obviously personal issues, you shouldn't make them public, so you send emails to me. But otherwise, it's not that I'm not trying to answer to you, but if I answer a question, I dedicate 5 minutes to answer one question in an email. That is only 5 minutes worth of my time. But if I answer that question in a forum, the value we get is multiplied by all the people that can read the forum. So it's a much more efficient use of my time, and the time I'm not using for answering emails, I'm using to put more work on the material in the unit. Okay, I hope my answers help you understand these topics, and I see you in the next Q&A. Bye.